All right. We are adding, subtracting, and multiplying radical expressions. So just combining them in different ways. If you can combine them, it's because they are like, okay? That means they need the same index, which is this number up here. If there's no number up here, it's an understood 2, index of 2. You can also call it a root of 2, or a radical of 2. But then you have something called the radicand, which is the inside or under the radical, okay? So in this case, the root is 3, the radicand is 80. If you want to combine them like you are combining like terms, they need to have the same index and the same radicand, okay? Like radicals can be combined with addition or subtraction by using the distributive property, okay? So working to combine radicals is similar to working to combine like terms, okay? When you have, for example, if you had x squared, I know this is very old, plus x minus 5x plus 3, you can combine x minus 5x and call it negative 4x, right? So that becomes x squared minus 4x plus 3. So if they have the same index and the same radicand, you can combine them. One more time, I'm just gonna say like, this one is an index to, sorry, it's kind of slanted, radicand 16. All right. So example would be 2, there's a number in front of it, 2 times the cubed root of 10 plus the square root of 10 minus 6 cubed root 10. Good. So what we want to understand is that these you can kind of treat like a variable, just in that we're counting how many. We have 2 cubed roots of 10. You could also write that as a cubed root of 10, cubed root of 10. Right? There are 2 of them here. So that means there's 1 square root of 10, and there's negative 6 cubed roots of 10. So it's just a variable in terms of there are 2 of whatever this is. There is, if there's nothing in front of it, we think there is 1 of whatever this is. There are negative 6 of whatever this is. Okay. So again, 2 third root 10 plus square root of 10 minus 6 third root of 10 means for there to be the ability to make like terms and combine them, this has to be the same. And this has to be the same. Okay. So we cannot combine all 3 of these because though we have a 10 as the radicand, this one has a 3. This one has nothing. It's an understood 2. This one has a 3. Okay. So we can only combine good. 2 minus 6 becomes a negative 4. We would leave it like that. And I guess we could, yeah, we would leave it like that. We could leave, yep, looks good. That's what you should know. A bit drawn out that time. Okay. Now we are going to add or subtract. Okay. If you have this.
Sorry, can
Yes.
you read that last slide for just one more second? I
Yes.
didn't get to adding everything.
Definitely.
Thank you.
No problem. Thanks for telling me. All right. So just like the previous slide, it was, they have to have the same index, same radicand. This number up here and this number down here have to be the same. And because they are numbers, there are no variables, you can check the answer in your calculator after you find your answer. So your index is going to be up here. That's the only one that's a 3. Everybody else is a 2. And then your radicand is down here. The 3, the 2, the 5, the 3, and the 2. Good. Okay. So we are combining the square root of 3 plus 7 square roots of 3, right? When you are combining them, you're just saying, I'm adding them together. How many do I have now? I have the same radicand and I have the same index, so I can just count them. This is 1, right? So we're missing some numbers. They're just understood. If there's nothing in front of this, that means there's just one of them. If there's nothing here, it means it's a 2, right? So there's some information we must assume. 1 and 7 square root of 3s is just 8 square root of 3s. And you can also check this to make sure you can't simplify this, all right? We've done some simplifying of radicals, and we will do some in the examples. But once you do the adding, make sure that this isn't the square root of 9, right? Because then you could further simplify it. Now, 10 square root of 2 minus 4 square roots of 2. So we're just going to say that's 10 minus 4, right? Because it's the same index, same radicand. 10 minus 4 square roots of 2. How many square roots of 2 do we have? We have 6 square roots of 2. Here we have a square root of 5 and a square root of 3. We have the same index, but we don't have the same radicand, so that cannot be simplified. You just leave it as it is. You don't have to write anything. If you do write something, you're writing exactly what they gave you. Good. All right. Same problem here. So here we had different radicands. Now we have different indices. So you just leave it the same. You could put this one in front if you wanted. 4 cubed roots of 2 and a square root of 2. You can't simplify cubed root of 2 any further. You can't simplify the square root of 2 any further. They are not like radicals. All right. Here we are going on to something that is not in its simplest form as the radical itself. So square root of 3 is already in its simplest form. Square root of 2, simplest form. Square root of 5, simplest form, right? Because we have them in their prime factorizations and there's nothing we could take out, right? However, if you just have the square root of 27, there is a possibility that when you factor 27, you can get you can take something out, right? So the square root of 27, 27 can be divided by 9, right? And we get the number 3. 9 times 3 is 27. 9, we know, you can either say, I know 9 is a perfect square. Or you can say 9 is 2 3s. Because this is an understood 2, the 2 3s come out to the front and we have 3 square root of 3 as the square root of 27. Those are the same. This is the simplified version of the square root of 27. So you get 5.196, 3 square root of 3. You don't need to put a multiplication. You definitely don't put an addition sign. You should get the same number, okay? So the square root of 27 becomes 3 square root of 3 when we simplify it. And then we have 75. A good hint is if this, right? If I took 27 and divided it by 3, I got 9. 9's a perfect square, right? If I can combine these, what do I need this number? What do I need the 75 to become? It's now the square root of 75. I need it to become like this, where I can just put them together, right? 1 square root of 3 and 7 square root of 3. I need them both to have the same radicand. Yeah. So I know that this one has a radicand of 3 when I simplify it. So a good idea, if you know what you're doing, is take your second term, divide it by what was left under here. because I want this one to have a 3 left over too. All right, because then I can combine them. So 75 divided by 3 is 25. Or you can do a factor tree. Or you can make a list of squares, 9, 16, 25, and see which one goes into 75. So 75 we said was 3 times 25 because we wanted to have the same radicand as 3 squared 3. I know that 25 becomes 5 and 5, or is a perfect square. So that becomes 5 square root 3, right? 27, the square root of 27 becomes 3 square root of 3. The square root of 75 becomes, 5 square root of 3. I wanted to put the plus like as a neutral color, but it doesn't matter. Good. And we checked it, right? We said the square root of 27 is the same decimal as 3 square root of 3. We can do it with 75. The square root of 75 and 5 square root of 3 are both 8.66. Now, definitely stop me if anything doesn't make sense, right? Because this is review. This is from the other parts of chapter 7. So you have to be strong on that. And then if you want to trick, whenever you find the simplest form of this, divide this number by that number to speed things up. And now we're just talking about combining them. So that's the hard part, is still just simplifying the radical expression, like taking the 75 and turning it into the 5 square root of 3. Now I have 3 square root of 5s and 5. Oh, 3 square root of 3s. Doesn't make sense at all. That wouldn't have worked. I have 3 square root of 3s and I have a positive 5 square root of 3s. So that's the same index of 2, same radicand of 3, even though I wrote it wrong as 5 initially. 3 and 5 square roots of 3, which is just 8 square root of 3. I strongly encourage you to put it all in your calculator just to make sure, okay? Unless it's a low stake situation like homework. So the square root of 27 plus, make sure that plus isn't under the radical, the square root of 75 is the same as 8 square root of 3. Now I have 3 square root of 20 minus 7 square root of 45. So this is even more complex than this one, because this one we didn't have any number in front, right? Here we're going to simplify square root of 20 and we already have a 3 in front. So when you have a number in front, if this was, so we know, I don't want to confuse what we've already written here. We know that the square root of 27 becomes 3 square root of 3, right? I'm going to write it twice. Because if you happen to have a number in front of the square root of 27, like the number 4, that means that you're going to multiply that 3 that you took out by 4, and what you'll end up with is 12 square root of 3. Okay, so as you're taking these numbers out, if there's already a number in front, multiply them. Okay, so the square root of 27 is 3 square root of 3, but 4 square roots of 27 becomes 12 square roots of 3. If you pull a number out, multiply it by the number that's already outside. Sound good? Okay, let's go to the square root of 20, just like we did the square root of 27. Also, you can start, if 45 looks easier to you, you can start with 45 and then use this trick where you divide 20 by whatever you pulled out from 45. Okay, so we'll start with 20. But you can start wherever you like. 20 becomes, I don't know. Well, what are my factors? What are my perfect squares? 4, right? 4 is a perfect square. 4 times 5 is 20. So 4 becomes 2 times 2. That's why it's a perfect square. 5 is just 5 because it's prime. So the square root of 20 becomes the square root of 2 times 2 times 5. Those 2 2's come out. So I have 2 square root of 5. Negative 15 square root of 5. It is. Bravo. Bravo, you are correct. Very fast. So 3 square root of 20 becomes, I only am looking at the square root of 20 right here, becomes 3, just bring that 3 down immediately, times this. So don't forget if you have a number in front, okay? Then we have -7 square root 45. So why am I this way? Why do I just write whatever I want while saying? I didn't even remember what it's saying. Ignore. Okay. So we bring that 3 down. We multiply it by 2 square root 5. Good. The 3 times the 2 becomes 6 square root 5. Okay. Now that I know that this is my radicand, I want to take 45 and divide it by 5 and hope that whatever the answer is to 45 divided by 5 is a perfect square, right? So here's 45. 45, when we divide it by 5, we get 9, right? And 9 is a perfect square because 9 is 3 times 3. So now we have 5 times 3 times 3. We can take the 3 out from under the radical and we just get 3 square root 5. Instead of the 45. But remember that we have that 7. It's actually a -7 in front that we're going to multiply that 3 by, right? So 3 times 7, 21. -7 times 3, 21, -21. So we have 6 square root 5 minus 21 square root of 5. Now I have the same index, same radicand. I can combine them. 6 minus 21 of them is -15 of them. And again, you can put it in your calculator. You can say 3 square root 20 minus 7 square root 45. Make sure it's not under the radical anymore, okay? Minus 7 square root 45. It's going to give you a decimal, but then put -15 times the square root of 5 in there, and you get that same decimal. All right, example 3. We have a negative radical and a positive and then another negative. Don't worry, this is not a negative under the radical, so we can still work with it, all right? Just like this says negative square root of 75. It's like saying it's a -1 square root 75. Okay, so the negative is outside of the radical. Negative, just like this is a -3, this is a -1. Okay, so the rule doesn't change just because we now have 3 terms. The rule doesn't change if we add variables. Okay, we're just going to continue simplifying the radical expressions the same way we were doing it before. So square root of 75. Did we already do that one? We said it was, right? We needed to change it to 3. Or again, you can say 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And you can look at 75 and say, oh, 25 is a factor of 75. 75 divided by 25 is 3, right? So the square root of 75 is also the square root of 25 times 3. 25 becomes 5 times 5 because it's a perfect square. And then 3 is prime, so it stays 3. The 5s come out. It's 5 square root 3, which I know we've already done. But it's a negative. So just like before, we put the 7 in front and multiplied it by the 3. Sorry, the -7 in front and multiplied it by the 3 to become a -21. Now I took out a 5, but I just need to keep that negative. So it's a negative that you kept from the original expression, and then you're multiplying that negative by a 5 square root 3. Good. 12. I'm thinking, okay, it has to have a radicand of 3 if I can combine it. Okay, maybe you can't combine it. Ooh, and I should have looked at all 3 of them, right? I should have said, this is 75, this is 12, and this is 3. 3 is prime, so I should try dividing 75 by 3 to get them all to a radical of 3 state. That would have been smart. All right, let's go on to 12. Since we have square root 3 and square root 3, I'm going to hope that 12 can be divided by 3 and a perfect square. When I take 12 and I divide it by 3, I get 4, right? And 4 is a perfect square. It's 2 times 2. Good. Those 2's come out. The square root of 12 is also known as 2 square root of 3 in its simplest form. There is nothing in front of the 12, so we just say plus 2 square root of 3. Sound good? As I said, the 3 is a prime number, so that's not going to change. So we can just bring down the negative 3 square root of 3. Now we just make sure that all 3 of those terms have the same index, the number up in the corner, and the same radicand before we combine them, right? So our index here is 2. And our radicand is 3, so we can combine them. Negative 5 plus 2 minus 3 square roots of 3. Right? And I should probably be putting these in parentheses so that we know that this is multiplication. Negative 5 plus 2 becomes a negative 3, right? Negative 3 minus 3 becomes a negative 6. So our final answer is negative 6 square root of 3. Again, you can put negative 6 square root of 3 into your calculator, and then you can put negative 75 plus square root of 12 minus 3 square root of 3 into your calculator. Make sure you have a square root there. I know I misspoke. And you should get the same number. To save time, I will not do that one. Okay. So what lesson did I learn? What did I do that was not the fastest in that first example? I didn't look for my smallest radicand and say, if that can't get any smaller, maybe I should try dividing that by that. Yeah. 3 is a prime number. It's not going to get any smaller than that. Maybe I should divide 12 by 3 and divide the 75 by the 3, right? So that's an idea. 5 is my smallest radicand, right? So as I'm simplifying, 3 square root 45x cubed plus x square root 5x, I can think maybe I should take 45 and divide it by 5. When I take 45 and divide it by 5, I get 9, right? Because 5 times 9 is 45. Sorry, I keep using the same examples. 45, 75, 27. 9, I know, is a perfect square. So it becomes 5 times 3 times 3. The 3 comes out and it's 3 square root of 5. Okay, so that's just the 45 is 3 square root of 5. And then that x cubed, what I should do, pretend I never wrote that. I'm going to put the 3 here, give it some space. And I'm going to put the 5 here, give it some space behind. Okay, so that was just the 45. That was just the 45 becomes the 5 and the 3, right? Not that 3. That 3 is still way out here. That's that one. This 3 is from the 45. We see it over here. This 3 is still this situation. Also, this marker is dead. Good. Okay. Now we have the x cubed. x cubed, remember, if this is a 2, you can take that 3 and divide it by 2 and say 3 divided by 2 is 1x with a remainder of 1. Or you can say x cubed is the same as x times x times x, right? And the 2 x's can come out. Okay, so x cubed is going to look like 1x outside the radical, 1x left under the radical. So 45x cubed, the square root of 45x cubed becomes 3x square root 5x. Good. Now, we still need to multiply 3 times 3x. 3 times 3 is 9x square root 5x. So 3 square root 45x cubed becomes 9x square root 5x. Good. Keep going. Oh, this is already in the form of square root 5x. That's nice. This is a hard one because now we have to combine this and this. So not only do you have the square root of 5x to combine, you also have an x in front of it, but that's okay. We're still just counting the x's, okay? This is 9x, and this is 1, right? And understood 1x. 9x and 1x become 10x's, okay? Or 9x square root 5x plus 1x square root 5x become 10x square root 5x. So if you want to, you can think of all of this as one term, and you're combining the 9 and the 1 of them. Good. All right. Let's simplify the cube root of 64 plus the cube root of 14 minus 9. Neither of those are primes, right? But the cube root of 64 and the cube root of 14, which one looks easier? 14 is small, right? So can you factor 14 and divide it by a perfect cube? Remember, the cubes are different than the perfect squares. Perfect cubes are 2 to the third is 8. 3 to the third is 27. So they're bigger, right? 14, you can only divide it by 2 and 7, right? And neither of those are perfect cubes. So that's already in its simplest form. So we're just going to call that 14. The third root of 14. Good. Okay. So can I take 64 and divide it by 14? No. Is 64 a perfect cube? So we know 2 to the third is 8, 3 to the third is 27, 4 to the third is 64. So the third root of 64 is 4. Good. Or you can do the factor tree, right? And you can say 64 is 8 times 8. 8 is 2 times 4 times 2 times 2, right? But we know that the cube root of 64 is just the number 4. So we have 4 plus the cube root of 14 minus 9. So we're not combining the radical expressions. We're combining the 4 minus 9. 4 minus 9 is just a negative 5. Right? So we have, and it doesn't matter if the negative 5 is up here or behind it, negative 5 plus the cubed root of 14. That is not the same as, okay? Negative 5 plus the cubed root of 14 is not going to be the same as negative 5 times the cubed root of 14. So make sure you notice the difference. Okay. That's all. There's one of those. There's -5 of those. Example 5. Subtract. Okay. So we're incorporating the rules for fractions with the rules for radicals. Assume all variables represent positive real numbers. Well, there's no variables here, so it's okay. So we have square root of 45 divided by 4 minus the square root of 5 over 3. Okay. The square root of 45 and the square root of 5. We can see, does 45, I know we've done this a few times, does 45 go into 5? Yes, it's 5 and 9. So that is 3 square root of 5, right? So we're going to call this 3 square root of 5 over 4 minus the square root of 5 over 3. Good. To get rid of, or sorry, to subtract or add fractions, we have to have the same denominator. 4 and 3 are not the same, right? But we want to find a least common multiple, least common denominator, either word works. 4, 4, and 3. So 4 times 3 is 12. So 12 is going to be your least common denominator. To get 12 here, I'm going to multiply 3 times 4, right? Anything I do to the bottom, I do to the top. To get 12 here, I'm going to multiply 4 times 3. Anything I do to the bottom, I do to the top. Okay, so 3 times 3 square root 5 becomes 9 square root 5. 3 times 4 becomes that 12 we wanted. Keep the minus sign. The square root of 5 times 4 is just 4 square root of 5. The 4 times the 3 is that 12 we wanted. Okay, now we have a common denominator. We can just combine them. Okay, so we, yes, that's correct. It's like, how do we go from square root of 5 to 4 square root of 5? So now we have, keep the denominator, combine these. So it was 9 minus 4 of them, right? Just subtract. 9 minus 4 is 5 of them over 12. Okay, I encourage you to put this into your calculator and put this into your calculator. Make sure you get the same decimal. Okay. This was the smallest number that 4 and 3 go into evenly, the number 12. That's why we picked it. Okay. Multiplying and dividing is a little bit easier than adding and subtracting fractions, right? Because multiplying and dividing fractions, you can just go straight across. But if you're adding them or subtracting them, you need to change them to the same common denominator, okay? And it always works to just multiply this denominator by this whole fraction and this denominator by this whole fraction if you don't know what else to do. All right, let's multiply radicals. To multiply radicals, just multiply what is under the radical together, so the radicand, and multiply what is outside the radical together. Sound good? It's okay because everything's under the radical. There's no, it's either all under or not under, yeah? So the square root of 3 times the square root of 3. We're just distributing the square root of 3 here. Okay, if you put into your calculator the square root of 3 times the square root of 3, you get the answer 3. Because what you're doing is you're saying the square root of 3 times 3, which is 3 times 3 is 9, right? And the square root of 9 is 3. So you're just multiplying. Square root of 3 times the square root of 3 is the square root of 9, which is 3. So if you ever have a square root times itself, you can just take it straight out of the square root symbol. Minus 3 times 2, so that's just the square root of 6, right? 6 is in its simplest form because it can only be divided into 3 times 2, and neither of those are perfect squares. So we just have 3 minus The square root of 6 as our answer. We distributed the 3. Sorry, we distributed the square root of 3, and then we simplified if possible. Okay, it was not possible to simplify the 6. It was possible to simplify the 9. Here, that was just distributing one term, right? Now we're going to FOIL it, distribute both the terms. Square root of 3 times the square root of 3, we just saw it, becomes 3, right? Because it's 9. The square root of 9 is 3. It's just a FOIL. So outside, remember, do the outside, the terms that are outside the radical together, and the terms that are inside the radical are multiplied together. So that is just positive 8 square root 3. That's all you have to do. Okay, because there's no way that those are two different parts, so they don't get multiplied together. Negative 8, or their form doesn't change, right? This one was outside, this one's inside. So we have plus 8 square root of 3 minus 8 square root of 3. Then we have a negative 8 times a positive 8 is a negative 64. Good. And then we can simplify it just like we simplified the square root of 3 times 3 is 9, square root of 9, which is 3. Then we have a positive 8 square root of 3, and we have a negative 8 square root of 3. So those cancel each other out, leaving you with nothing. So we have 3 minus 64. So the answer to this, even though it looks very complex, because it is positive, negative 8 and positive 8, and these are the same. These are the same. A and B are the same. One's negative, one's positive. They cancel each other out, and you're just left with a real number, no radical. I guess a radical is a real number. All right. I don't think we need to do this. This is not on. This is not in my math lab. I'm going to stop the recording, and we are not going to worry about this. I will do one more. Sorry. I will do one more. If it is, don't worry about this where we're adding things underneath it, but do worry about just a regular radical and a whole number squared. Okay, sorry, got your hopes up that we were leaving. So what would I do with this? The 2 outside parentheses means we're multiplying that whole thing times itself. So that just means we're FOILing again. The square root of 3 plus 2, square root of 3 plus 2. They're being multiplied by each other. Okay, so again, we're just FOILing. Okay, first is going to be the square root of 9 again. Outside is going to be a positive 2 square root of 3. Inside is going to be exactly the same as the outside, because if we're doing the same, multiplying the same 2 terms, right? Another 2 square root of 3. And then the last one, oops, first outside, inside. Last is just 2 times 2 is a positive 4. Good. So the square root of 9, we know becomes 3. 2 square root of 3 and 2 square root of 3, that's the same radical. Sorry, the same radicand, same index, so we call it 4 square root of 3 plus 4. Good. So our answer is 7 plus 4 square root of 3, or 4 square root of 3 plus 7.